Hi everyone, my name is Karian Jones and welcome to this lecture for Physics 1. Today we're diving into an exciting topic called linear momentum. I'll explain what it is, why it's important, and how it applies to real life with examples to make it clear. Without further ado, let's get started. So here's what we'll cover in this lecture. First, we'll define linear momentum and discuss the basic equation of it. And then we'll explore the principle of conservation of momentum and how it applies in collisions. Then I'll explain impulse and how it relates to momentum changes. And finally, we'll summarize everything we've learned with a quick recap. So we're going to begin with the basics. What exactly is linear momentum? So linear momentum is a measure of an object's motion defined as the product of its mass and velocity. Mathematically, it's written as P equals M times VP, where P is momentum, M is mass, and V is velocity. Momentum is a vector quantity, meaning it has both magnitude and direction. So definition of linear momentum, we're just going to look at a small example. Example one, this is a box, but think of it as a car moving conservatively along the road. So this, if it will, this is what linear momentum will look like. This, the velocity of the car constantly moving along the road. Okay. So now we're going to get into conservation of momentum. One of the most important principles in physics is the conservation of momentum. In a closed system with no external forces, the total momentum remains constant. For example, when two ice skaters push off from each other, their combined momentum before and after the push stays the same. This principle is crucial in analyzing collisions and explosions. So I have an example problem here of two cars that have collided and are now going in opposite directions. This is that example. As you can see, the two cars were coming towards one another, collided, bounced off of one another, and are now going into separate directions. We use conservation of momentum to solve what the final velocity of the system would be after the collision. So next, we're going to move into impulse and momentum change. Impulse. Impulse is the change in momentum. Impulse is defined as the force applied to an object multiplied by the time it's applied. Impulse causes a change in momentum. So this concept is used in car airbags. By increasing the time of impact during a crash, the force on passengers decrease, reducing injury. It's a life-saving application of momentum principles. So linear momentum isn't just theoretical, it's everywhere in daily life. Some examples include sports, like a soccer ball's momentum depends on how hard and fast it's kicked. Space exploration, rockets use conservation of momentum to propel into space by expelling gases backwards. And transportation safety, finally, where momentum principles improve designs for seatbelts, helmets, and crash barriers. So I want to discuss some examples that I had talked about a second ago of the three um, real life applications, such as sports, space exploration with the rockets, and transportation safety with the airbags. So, as I once said, a soccer ball's momentum depends on how hard and fast it's kicked. I have a visual representation of a soccer ball being kicked, a pretty big size soccer ball being kicked, and it being pushed a good distance. Let me see. So this is that example. As you can see, the person, and it has multiple factors such as how big or small the person is, the force of that person's kick, and how hard and fast. that the ball is kicked. So as you can see, the ball goes a pretty good distance from the kicker here. So this is a good example of linear momentum because the ball stayed in its on its path, but it's moving at a pretty good velocity. And then the next that I want to show the physical representation is of the rocket being propelled up into space because of the gas that's being expelled from the bottom. Because the gas is pushed from the bottom here, the rocket is pushed up, such as like a push up motion, as if you were to try to stand yourself up with your arms. It's the same example. You'll put your arms down and you'll press down with your arms, which will lift your body up. That's the same example as with the rocket. The gas is expelled at the bottom, pushes the rocket up into the air, and that's a linear motion right up into the air. And then the final example that I wanted to talk about was the airbags in the cars, um, which are the safety nets of any collision or something like that. If an airbag is deployed, the car is going to be backwards, pushed backwards. Same as if it's in a collision, because it will literally, the two things will look like this and it will go like that. So the cars will be coming towards each other and going like that. So here is that physical representation of the car having its airbag deployed. It was on its way going this way, but it was pushed backwards once the airbag was deployed after the collision of the hypothetical ghost car over here. So that's all I wanted to talk about for the examples of the real life application examples of linear momentum. So to recap today, um, this lecture or this talk was over linear momentum. Linear momentum. So linear momentum is defined as T equals M times VP. Okay, it's a key measure of motion. The second key point is that the conservation of momentum explains how momentum is constant in closed systems. And then the final key point is that impulse relates force to changes in momentum with practical uses like airbags and safety equipment. So linear momentum isn't just physics. It's part of our daily lives, from sports to safety to space travel and all types of other things. Thanks for watching, and feel free to ask me any questions in the comments and I will try to answer them. Thank you so much. This has been Carrie Jones discussing linear momentum, and it's been a pleasure.